Warning! Tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Back for another episode on Spud 2.0. As you can see, we're getting near the end here. We've got the input tubes to wire up, and then after that, running some RCA jack wiring and some of that other kind of stuff and get the volume control mounted up, and we're going to be putting this thing on the audio analyzer suite, seeing what we end up with. Again, I've said this almost every episode. Do not build this thing until I test it. This is an untested design. You know, some people might say, why are you even making a video series about it if you don't even know if it's going to sound good? Well, kind of have to make it as I go along, and I publish my videos live, and if this ends up being a disaster, well, it just does, and you can watch me crash and burn on my channel. So anyway, hope you're enjoying this as much as I am building this. I just love doing stuff like this, and especially the challenge of trying to fit all of this in this little tiny chassis. And so it's been fun for me. Again, I hope you're enjoying this too. And if this does turn out good, I think you'll have fun building this thing. So let's get busy finishing this up. So you can see, as a follow-up to our last video, I moved this 750 ohm 5 watt cathode resistor for the pentode over here across from this little slot that I put in the top of the amplifier, and kind of down low closer to it so that the heat from this thing can go out through this slot. And for now, we've got the bypass capacitor removed to make the wiring of this other stuff easier, and we'll put that guy in once we get this other tube wiring. So let's go over that. Okay, let me show you real quick how we calculate up this resistor to add to the LED. So we know that 2 volts across 680 ohms is what's going to be on the cathode if we just use the resistor according to Kegger's schematic. So we're going to calculate up the milliamps. So now we know that we need another 0.4 volts over the 1.6 volts of the LED. So we come up here and put in 0.4 volts. We clear that and this. Calculate 136 ohms, which I think probably 150 ohm resistors, the closest one I'm going to have, but I'll look through my resistors and see if I have anything closer. But that'll get the voltage really close to what we're looking for. So we're going to add this 150 ohms to the red LED, and that should get the cathode voltage where we want to see it. So in this video, we're going to finish up the tube wiring, and this should go pretty easy since we've planned ahead for this. So right here we have the grid leak resistor for the input tube or input triode, and I put these in all my amps, even though most of the grid leak current is going to go through the potentiometer. This is here in case the wiper fails on the potentiometer, that the grid always has a path to ground through this 1 meg resistor. And then next we have the LED that's on the cathode of the triode. And as you can see, these are little tiny red LEDs, and I'll put a link in the description what these are. These were chosen for their sonic qualities. These really do sound good. So don't just stick any old red LED in there. Make sure you use these little guys. And these have a 1.6 volt drop. Then we're going to put a 160 ohm resistor between here and here, here and here. And that's closest to the 150 ohm that I showed you earlier. And that should be close enough for getting this cathode voltage where we want to see it. So let's move over here to the plate side of the triode. This is the plate. We're going to put our plate load resistor 51K between here and here. Then we're going to put our shade feedback or plate to plate resistor from here to here, which is a 300K. So here to here, again, 51K, 300K across these two. And then on this terminal, this is going to be where the grid of the pentode is connected. So we're going to hook our grid stopper, which is a 2.7K, between here and there. From here to there. Again, a 2.7K grid stopper. Then we'll put our coupling cap between this plate and this terminal, which is going to the grid of the pentode. So the plate of the triode to the grid of the pentode, plate of the triode, grid of the pentode. Then over here on this side again, we have our grid terminal point for the input tube. We're going to put our grid stopper for the input tube between here and there. It's a 510 ohm. Grid stopper for the grid from here to there, 510 ohm. And the last thing we need to do is get power over to the plate of the triode. So over here on this tag strip, we're going to put a dropping resistor between the B plus terminal here and this terminal with this filtering cap. Same over here. This creates the RC or resistor capacitor filter for the input plate. And then we're going to run a wire from this terminal over to here. Same thing, wire from this terminal to here. And that will power up the plate of the input triode. Once we get all that connected, we can power the tube up. Main thing we're going to be checking, we want to see what our plate voltage is on the input triode. And I'm hoping to see somewhere between 150 and 170 volts, something like that. And it's calling for 155, but anything between like 150 and 170 would work fine. And then on the cathode of the triode, we're looking to see 2 volts. And we may possibly have to adjust this 2.7K dropping resistor or adjust the value of this plate load resistor to get this voltage where we want to see it. So let me get these parts installed and we'll get ready to power this thing up and check the voltages on our input triode. And if that all works out, all we have left is to hook up the RCA jacks and then the signal wires over to the volume control, and then the wires of the volume control over here to the grid and the ground on the 2 input triodes to get our signal into the amplifier, and we can go test this thing. So let's look at calculating up this dropping resistor that we need to put in the RC filter feeding the plate of this input triode. So first, we know we got 2.9 approximately milliamps going across that tube. And so we also know we've got a 51K plate load resistor. So that means we're going to have 148 volts of drop across that plate load resistor. So we got 320 volts of B plus minus this 148 volts. That puts us at 172 volts on the plate. Well, our target is around 155. And so we need to drop another 15 volts or so across that dropping resistor feeding the plate of that triode or the plate load resistor. So let's go back to our calculator up here. So again, the 2.9 milliamps is across the tube. We'll clear these 2 fields. And then here we'll put our 15 volts. And we need a little over 5K of resistance to get that 15 volts of drop. And I think I'm going to go with a 5.7K because I've got some of those on hand. And let's see what drop that gives us. 16.5 volts. That'll get us really close to the 155 volts we're looking at. Now again, this is just an estimation calculation. It may not be exactly that, but it should be, between 155 and 160 volts going with a 5.7K resistor. Now, if I go back to Kager's original design, he may have been using a common voltage drop for both triodes. A lot of amps do that. And I think it's kind of unusual the way I do it using separate ones. So let's do this calculation based on that assumption. So if we come back up here, if we have both tubes feeding off of the same dropping resistor, we'd end up with 5.8K and the same 15 volts of drop we're looking for. There we go. That's right at the 2.7K that he put in his design. So if you were going to use a single dropping resistor and 133 UF cap for both channels, a 2.7K would work fine. But since I've separated them, we then need to basically double the resistance value, which would be 5.4K. I've got a 5.7K, so we're going to go with that. Okay, let's go over the parts we've got installed in the amp now. Okay, these white wires here are coming over to this power supply strip here where we installed our dropping resistors and the filtering caps. And again, I'm using one for each channel. You could build this with one of these for both channels, but I prefer doing them like this, where each channel has its own dropping resistor and capacitor. As I showed you in the previous segment, we ended up going with a 5.7K resistor for each channel, and if you did a combo for both channels, you would cut that in half, or something around 2.7K. So we have our voltage coming over here to this point on this tag strip, and this point we have our 51K plate resistor going to the two plates. This resistor right here is the shade feedback resistor that goes between the plate of the input triode and the plate of the pentode. So this tag point right here is going to be where we connect the coupling cap from the plate over to this point, and then this and this are the grid stoppers for the output pentode. And again, this is the grid leak resistor for the output pentode. These are the ultralinear wires from the transformer that have their screen stopper 1.2K resistor made into the end of the wire with some heat shrink tubing. This is the cathode of the pentode. Comes over to these pins here, which then have this cathode resistor, 750 ohm, that goes from this terminal to ground, and then the bypass cap goes across them. This is the 1 meg grid leak resistor for the input tube, or the input triode. This is the grid stop resistor for the input tube, or the input triode. It comes up to this pin here. So when we wire up the signal wiring, this is going to be the positive signal, and then we're going to hook the ground of the signal cable up here. So it'll be signal and ground. This is the cathode of the input triode, which is this pin here. Got the LED that goes from here to there, and then we have our 160 ohm resistor that goes from here to here, from here to here, and we're hoping to see around 2 volts on this pin right here. Anything from 2 to 2.2 volts, something around there, should work just fine. So now we're ready to power this thing up again, and we're going to check all the voltages on the front end, and if they all turn out good, Then we'll be done with wiring up the tubes, and all we have to do then is wire up the RCA jacks and the volume control, and we'll be ready to test this amp out. So let me zoom out a little bit here so you can see the voltmeter. Okay. And let's connect the power cord and power this thing up. Again, we have our test ground lead connected to the ground point with this little clip so that we can come in and check the voltages with our probe with one hand behind our back. The other thing I'm going to do out of abundance of caution is I'm going to go ahead and hook dummy loads up to the outputs, even though we don't have any signal going in, just in case there's some stray oscillation. We don't have a problem that could end up damaging our output transformer. So we'll put this on DC volts, get our probe all ready and untangled before we turn the power on, so we're ready to go. And here we go. Give this thing a minute to warm up and stabilize before we start checking our voltages. And I don't know if you can see in the video, but the LEDs just lit up. That means the input triodes are conducting current. And once we see our 36-ish volts on the cathode of the output pentode, we should be warmed up enough to come in here and start checking voltages. There's 34. There's 35. Let's give this thing another minute just to warm up good. Check our B plus voltage there. We have, here we go, we got our 35, 36 volts on the cathode. Amp's good and warmed up. Let's check these other voltages now. So we're looking for between 155 and 170 volts on the plate of the input triode after this plate load resistor. And there's 167. It's a little higher than I was expecting to see, but there's 165, 164. We can live with that. And this would be just under 300 volts after the voltage drop resistor in our power supply. So we got 298, 299, then we got 313. This should be 313 as well. So we got basically 14 volts of drop across that 5.7K resistor, and I'd calculated 15, so we're within a volt of what I was expecting. And there's 2.14 volts on that cathode. 2.14 volts on that one. So we've got the correct voltage on the cathode of the input triode. And really, I think we're good to go now. We've checked all these other voltages. Again, we can kind of run through and look at some of these other ones one more time. This is the plate of the output pentode, 305, 305, ultralinear tap, 304, 304, 305, right where we wanted to see them. That's on the screen of the output pentode, and then on the cathode, there's 35 on that one, and a little over 36, close to 37 on that one. Perfectly fine with all of those voltages. So now I think we're done. We got the tubes wired up. We're ready to get the signal wires connected to the grid of the input triode, and see what this thing's going to sound like. And then I decided one last thing before we put a bow on this thing. I'm going to plug this thing into the wall outlet, not using the variac or the isolation transformer, and just run through these voltages real quick to see what the final as connected to the wall outlet are. And we've got 317, should be the same on both of those. Over here on the plate of the triode, got 168, 164. Then on the plate of the pentode, got basically 310, 310. On the screen, 309, 309. Then over here on the cathode, 37, 36. On the cathode of the input triode, 2.15, 2.14. All those look awesome. So let's wrap this up right here. Well, as you can see, we're making good progress on this build. And I know in this build I'm doing this more step by step rather than solder joint by solder joint. And I think you guys have seen me soldering stuff before. Maybe some of y'all really like those kind of videos. I am planning on doing a kind of ASMR, whatever they call that, building a circuit board and just hours of soldering. So, hey, for you folks to enjoy that stuff, that's going to be coming soon. Anyway, back to this guy. As you can see, we're going to be hooking this thing up to the audio analyzer suite soon, seeing what kind of performance we get out of this thing. Hopefully this thing knocks it out of the park and is at least as good sounding as that 6BM8 amp is. I think it's going to be even better. So, if you're enjoying this content, please subscribe to the channel. Please like the video. Thanks again to you Patreon supporters and folks that have donated to my website. I really appreciate the love there. And until next time, have a nice day.